Okay, we're live. Apparently I've spelt real time wrong. What are you gonna do? We're gonna put some water on this board and we're gonna watch it destroy itself. Just want to show everybody how quick damage can happen on these devices. I'm just going to zoom in because I think I'm going to change my lens. We're going to start off here down by VC Bat. And let's just get this focused in. And I'm going to see if anything happens down here. So there's not a lot. There's not a lot going on down there. See if there's anywhere else. There seems like a lot of caps around here. Let's see if there's what that is. Just gonna zoom out. I mean, PMIC's there. So PMIC is going to control all the voltages coming in and out. So yeah, that's probably a good place to start. Let's look here. Just want to have a quick look at what lines they are. Ground. Okay, 5V Sage, ground, V boost. Lots of different lines around here. Okay, yeah, that's a good place to start, I think. And there's VC main. Cool. Okay, so where's VC main? We're looking for two caps. That's VC main. Okie dokie. So yeah, lots of potential destruction. So, yeah, we've still got a camera. We haven't got anyone watching. No one wants us to see us destroy this board live. So we're going to connect the power, and you can see that it's pulling no power down the bottom. So I disconnect that. So it hasn't got a short already. So you can see that there it's connected. Just going to have a look at the power here. Just want to check that we are actually... And Sophie's watching. Test. Chat. Okay. Just want to see if chat's working. And we're going to cut straight to it. Okay, so for once, there's not that many people in it. So I need to make sure this clamp stays on, so try and move this around. There we go. Okay, so that's where PMIC is. Okay, so we've got... Let's see if we've got any voltage going through those, because it's going to be completely pointless if there's no voltage going through the board. So let's go for the VC main caps. Yep. Oh. Go away. You're not wanted. Okay, so I'm going to need to work out a way of clamping this on, because it's not going to stay on, I don't think. Could you get me a elastic band, please?
size?
The smallest possible. Let's see if I can put this on with some elastic, keep it on there. Maybe go for... In fact, don't worry about it, I'm going to clamp it. Well, I say don't worry about it, I don't know if the clamp's going to work, so...
Get one anyway. Small enough?
Nope, but I'll make it work. Yes, Jin. Yes, Dave. Dave's watching, he wants to see us destroy an iPhone 5. Okay, yeah, I think that's going to work. Let me just measure that again. Just want to make sure there's voltage here before I start pouring water onto this board.
Better?
No, exactly the same. Oh, no, it's marginally smaller. But no, it's
two small ones I can find.
Ba-dum-bum-ch. They were the only two small ones he could find. I'm alright, Dave. How are you? Okay. Yes. Okay, that's not getting any voltage. Let's try Isaac's elastic bands. I don't think that's going to work either. No. Never use these 5G ones. Okay, how can I think I've got an idea. You're rough. What's wrong with you? Okay, we've got that. We've got that clamped. No, clearly not. Okay, who would have thought the hardest part of this was getting the power to stay in? I need to make sure this is going to stay in properly because I'm only going to get one shot of pouring liquid onto this board. Okay. That looks like... Okay, it's not wanting to play ball. on, stay on, you prick. Okay, I think I've got you. It's because the leads on the back of this are at an angle, and every time I clamp this up it's forcing the angle. Stay on, you wee bastard. Hey. Okay, Dave's gone. Dave's had enough. Dave didn't want to stick around and find out what was going on. Dave was like, I ain't got time for this skiing. Just cut to the chase. I want to see you destroy a board, but you're just waffling crap for 12 minutes and you can't even put power into a board. Okay, I think I've done it. Shh, there's people outside. Have they gone, Isaac? We're closed. Go away. I haven't seen anyone leave from the door yet. Is that door closed upstairs? Yes. Hey, we've got power. Now we can work. Okay, so I got this. Can we see that? This is the smallest needle that I could find, courtesy of Gibson Gunnell. So that there is the smallest amount of liquid. So we've got, is that how you do it? Is that how smackheads do it? They flick this needle like this. And they push all of the air up to the top, kind of. Do this like a doctor. Got spray that crap out the top. There we go. Get all the air out. So we've got 3 ml of water in here. I'm not going to put that on. I'm not going to put anywhere near that on. I'm just going to put a drop in the centre of all these. Okay. To give you an idea of the size of what we're covering, that's a cotton bud. So you can see that cotton bud on the other camera there. That covers exactly what we're using. So very, very small amount of water. Phil Evans joined. Good timing, Phil. So we are just gonna okay. So let's set a timer. Now you can start to see the corrosion building straight away. I put 3 drops on there. I didn't want to put 3 drops on there. I wanted to put 1 drop. Okay. Right. How can I get that in the camera view? I can't. In fact, can you just about see that up there? No, you can't. I'll spin it round to me. So we're on about a minute now. And it's looking pretty horrendous. So you've dropped your phone down the toilet. And you haven't taken the battery out. You pulled it out really quickly. I mean, how much water did I put in this? So that is, what is that, 1/10 of a mil? I'd say that's 20th of a millimetre. No, 20th of a mil of liquid. So almost nothing. So you can see all of the bubbles starting to form. And this is just simple electrolysis. So if you've ever dropped your phone in the toilet, sticking it in rice isn't going to stop this. Drying the liquid out and stopping the electrons travelling, that's going to stop this. About 2 minutes in, everything looks quite silver, but it's starting to get cloudy. So we can see, I put a bit too much on, we can start to see that it's eating away further than I thought. I got a bit crazy with the old liquid and just started spraying it all over the place. Oh. So here we got VC main, which is 3.8. There's like, I think there's one V8 around here. So there's quite a lot of power rails all around here. There's some Sage rails. There's a few other rails. So we're on about 3 minutes. And it says we're drawing no power at the moment. It says we're drawing 0.1. But I don't think that's true, judging by the reaction that's happening. I'm probably going to give this 10 minutes. And then we'll clean it up and see what happens, see if it works. Dry it out. It'd be interesting to see how much damage happens in 10 minutes. So surely that's going to be dropping it in the toilet. And then what, sticking it in an oven? I don't know. I don't know how you dry it that quickly without getting it apart. I'm pretty convinced though, in 10 minutes there's going to be quite a lot of damage to the board. So let's zoom in and see if we can see anything else. Try and turn that down a bit. You can see it's starting to go murky now. You see all the bubbles starting to form. When it's going to start being drawn towards the most power. You can see that sort of hazy, milky looking stuff starting to form. That's probably something to do with the metals. You can see the liquid starting to move now. It's being dragged to other places. Now I'm not moving the desk. The desk is bolted to the wall and it's really, really sturdy. I'm not going to bang the desk because that's going to be counterproductive to prove, but you can see the water tension or the liquid tension is being broken by probably say the bubbles moving around. I mean, you can see at the top there around those 5-volt caps, it's really going crazy, and the VC main as well. It's starting to be dragged towards the PMC at the top there as well. That sort of square you can see at the top there, that's the power management chip. So that's the thing that takes in the voltage and then sends it all over your phone. So, but we are 5.5 minutes in. I didn't start the timer from, so give it a minute. Say we're 7 minutes in, but it's traveling across the screen. So you can see it started off just around that big, that big component in the middle, and it's working its way out slowly. If you look at the edges, you can see the liquid starting to travel further than it was to start off with. Like a good example, if you look at the top there, around the PMIC, it was nowhere near the PMIC before, but now the surface tension's being broken by the continuous bubbling, and it's just working its way across your board. So this is not moving around. So imagine if you drop this down the toilet and you're shaking all the water off it. You know, you're shaking this, just one tiny blob of water got through. One droplet. I mean, this is less than a drop of rain. This is not, you know, dropping it in a drink, knocking a drink over your phone. This is not, you know, spilling a coffee, dropping it in a puddle, kicking it along the floor, whatever you drop it in. So we're up to about 8 minutes. Gonna say, for some reason the comments aren't coming through Facebook. Let's see if we can go live to read comments. I am live. Comments aren't coming through. It says we're connected to. I don't know why. Let's reconnect Facebook's one, see if it reads it. So we're going to clean this up in 1 minute. Yeah, if you look at the top there, it's worked its way all the way along, and it's starting to go around the corner of it, so all right. It says we're drawing hardly anything, 0.02 amps, which is nothing. But you can see there that there is definite power because of the electrolysis. That cap at the top as well, that's starting to look hazy on one side. You've got the silver that you can notice, and then it's black on the other side. The black side is the voltage side of that cap. The other side is the ground side, so the ground side's not going to have any damage done because the power is being pulled through, obviously, the power side, and it will travel all through that power rail. So wherever they're connected, they're going to start looking like that. Anything that has this liquid, touch it. Now, certain power rails aren't going to have damage because certain power rails aren't going to be turned on by this point. So there's no voltage going to them, so there's no electrolysis happening, and it will just purely be coming down to corrosion. Now, corrosion you can't see in real time. You can only really see chemical reactions, which I believe electrolysis is a chemical reaction. You can correct me if I'm wrong on that. I'm not up on my physics and chemistry, but I'm pretty sure what we're seeing is a chemical reaction, and I'm pretty positive it's electrolysis. So depending on the liquid you drop in, depending on how fast those electrons are going to travel, depending on how fast it's going to eat away at whatever it's using. Okay, we're up to about 950 now. Let's call that 1050. So let's stop that. We're going to disconnect the power. So yeah, you seen we were pulling 0.02 amps. And I'm going to come in here and I'm going to soak this up. And I'm going to dry it with the heat. And make sure there's no liquid left under any of these. So 10 minutes that was, give or take. And you've seen before the board was. I should have taken a photo. Should have took a photo. I could have done a live comparison. I've been wanting to do this for ages, and I've seen Lewis Rossman do it the other day on a MacBook. But it kind of proved my initial thoughts that I was thinking that this is happening in seconds rather than minutes, or hours, or days. So leaving it for days wet is a bad idea. Leaving it with the battery connected is a bad idea. Sticking it in rice is a terrible idea. So we can see here. Let's have a look. I'm going to get that kind of framed properly. I think the top of this cap here looks wet, but that's just the way it is. So let's have a look around. So the initial drop I wanted to go here, but it seemed to have started to travel all the way out. We've got no power in here, but you can start to see here, see the corrosion on this. I'm going to get a better magnifying glass on this in a second and zoom right in so you can see the kind of destruction. You can see this sort of webbing that's starting to form between these two power points here. It's starting to form here. You've got it around here. It's starting to sort of dull these up. You've got the main power rails on here. This is 10 minutes on a good board. So 10 minutes. You didn't disconnect the battery because you didn't have a screwdriver, because Apple won't let you do that. And this is going on inside the phone. Okay, I mean this is as far as I can zoom in without changing the lenses on the microscope. Don't know how well that's going to translate. It's not bad. You can certainly see the destruction. Right, let's get in here and scrape one of these caps. Now you can see it's mild. You can see it's just taking the top coating of these caps. I mean, if I tin that up, we could probably bring that cap back, and that cap probably isn't damaged. And truth be known, this phone's probably not damaged. So let's see if we do something about this quickly. Let's clean this, and we'll see if clean Dodu team. I don't know what that is in Russian. I'm assuming it's Russian. I'm sorry, I don't know what that is. I don't know if you've got a translator there. We're going to clean this up and see what happens. So we're going to get some alcohol. Just clean this up. And we're going to see if that voltage comes back to that cap after we stop it from touching all the other caps. Which I imagine it will, because it hasn't been long enough to completely kill the board yet. And then we'll put some more liquid elsewhere. We'll put them maybe around an IC to see what happens around there. So let's get the dry up some of this alcohol. See stuff starting bubbling away. Just want to get rid of what's left on it. Let's plug the power back in. And we want to measure that VC main cap. And as it stands, we're only, there we go, but you could see there that it was fluctuating from 1.4 volts to 3.8. Now, if we come over here, we've got 3.8 on that cap, and 3.8 on that cap. So, if you get the liquid off quickly and you clean it, you can save the board. But you need to be quick, real quick, you know. I mean, we've seen 10 minutes and that's the damage that's caused. What I'm going to do is I'm just going to get a different lens. Just going to remove this camera. I'm going to gently put this over here. I'm going to get the highest lens that I can do and zoom right in on this just to see what level of destruction is there. Right, this is my ×2 lens. Is this my ×2 lens? Here's my ×2. No. Okie dokie. I have to get much further into focus. I think I might even have to remove that camera. Okay, so I don't know where I am on this board. Here we go. I mean, there is 0 working distance here. I don't know if you can see. But I mean, that there is the best magnification I can get. So let's move, just see if we can get just one of these caps in focus. Get one of these VC main caps. There you go. Look at those two bad boys. Okay, that's that focused. That I'm not going to be able to focus on the feet as well as that just because of how zoomed in that is. And I think it's only got a small... I'm not sure if I'm going to be able to get my tweezers in between there. Not at the right angle to try and scrape that away. It'd help if I disconnected the power. Yeah, I'm trying to scrape away at that to show you there is good metal underneath, and that's the thing we need. So let's zoom right out. So you can see the board looks in quite good condition under this lens. But I'm sure if we put more water on that, we're going to see a different reaction. Okay, so let's change back the lenses because that's just impossible to work under. And what we'll do is we'll pick another part of the board and I'll give it another 10 minutes and we'll see if we can get any chips I'm going to show you what happens when you put liquid near an IC. Once you put liquid near an IC, it tends to draw the liquid in. Okay, let's get this camera back on. Let's get these lenses out of the way. Okay, I'm just going to pick a place that's going to have some sort of voltage and ICs that aren't protected. I mean, down here is probably going to be a good... This is VC bat, so this is where the power directly comes in. So let's try and get that in a good camera, and we're going to put some more liquid. I'm not going to go too crazy with the liquid this time. I'm going to try and get one drop near this cap. Okay. Okay, so we got 3 drops. Every single one of them is on. So let's see what happens to these drops. See if they get vibrated off. I mean, that one at the top looks like it's okay in the cap. So straight away, we've got power. Let's reset the timer. If you're going to be able to see that up there. Okay, yeah, so you can see at the top, you can see the bubbles starting to form on that cap now. Now what will happen is the surface tension should break. It will drop, that water droplet should drop around that IC, and it should just be dragged underneath. I'm not overly familiar with the iPhone 5 motherboard, not to quote what parts of what, but I believe that is VC bat, and then that chip is a voltage divider. I might be wrong, but I think on one side is VC main and the other side is VC bat, and there's a data connection I think going to it. So interestingly, the cap down the bottom doesn't seem to be doing anything. I mean, that looks like fully submerged now, so maybe there's no power going to that. And the droplet that was on the, I don't know what that is. I think it's a coil. I don't know what type of coil. But yeah, that's not doing anything either. I don't think that's broke the surface tension. I'm going to see if I can focus in more on see if we can get further down. No, that's as far as in as I can get without switching the lenses again. I'm watching this on a 720p screen, so it's not the greatest. But you can see the bubbles starting to form under the chip, and it's dragged most of the liquid off the top of this chip. We haven't even got 0.5 ml we've used in 2 of these yet, so 0.5 ml of water is like nothing. Okay, so you can see that it's starting to evaporate on that chip now. So what's happened is VC main and VC bat, one of them's gone to ground, so it's causing heat, which has just evaporated that. This is the thing that does the damage. It will cause that IC to run red hot, and what's happened is it's been dragged underneath the chip, and it's everything underneath that IC now is connected. So if we go over to ZXW, Back over to the main camera, see what's happening. Don't know if I can see anything. Well, it's certainly taken the little cap and the other cap out. And we've got 0.01 pull. It looks like ZXW's crashed. So we'll come back to that. I think it's VC main. I'm pretty positive it's VC main. That's not even loading now. Okay, let's reload ZXW. Apparently the information's not found. What time are we on? 4.5 minutes. And by the looks of it, the liquid's nearly all gone. Yeah. So that whole area, actually, if I just zoom out, that whole area, the liquid's completely gone. So yeah, what's happened, it's caused a short underneath this IC, and it's made this part of the board so hot in 4 minutes that it's just evaporated all the liquid. I mean, you've got a mild little bit around these weld points, but I don't know if it's still got the short, because it's not pulling power, it's still pulling the 0.1. So it's not VC bat that is short. Okay, I'm just going to get the schematics back up for iPhone 5, ZXW. And let's go here. DC-DC mode. DC-DC enabled. Okay, that's interesting. And there's no VC main. Okay, is there a VC main that even comes near this? Bat VC, ground, bat VC. So PPA, I'm guessing, is PPA is probably not enabled. That's why there isn't any corrosion or anything happening around there. Well, I'm calling that at 6:30. So there's 6 minutes and 30. It looks like there is nothing left of the liquid. So not bad for a drop. And there's no pull. So just disconnect the power. I'm going to clean this up. Now this alcohol here should just disperse any liquid that's left on there. They don't like each other. They cannot coexist. Okay, just let that dry off. See there, that and there is corroded. And then what I'm going to do, I'll lift this chip in a sec. Just dry the liquid off. Okay, so that's 200. So this solder that they use around here apparently melts at 200. And I'm guessing all of this liquid here is the flux that they've left on the board, maybe? Because we've just been using tap water. If you use Coke or anything else like that, I imagine it's going to be even worse. The minerals are going to be attacking this a lot more. And I think what I'm going to do is I'll finish this up. We'll pull this chip. I'm going to pull this chip up, have a look underneath, see what damage is there, and then call that it. Power's disconnected. You see the liquid from this flux travel underneath that. Okay, sure. And you can see these spots around here where it started to attack these. This is like contamination of the flux. You see how clean it is here. It's brought all of the sort of contaminates to the top. But other than that, it's not been left on long enough for that to cause too much damage. Okay, so we've got a plus there. I'm guessing that's the right corner. A1. We're just going to put this one back on. See that flux getting drawn underneath. Be careful of those leads, they're starting to cook. There we go. That's it, little chip. Dance for me, boy. Okay, so that one's back in. Melted my leads a little bit, but what can you do? We're going to leave that cool down a bit, clean it off, and again, I think if we power that, we'll have the full voltages there. So, but it's a good little demonstration to show you how quickly liquid can attack a board with power in it. It's not magic or anything, it's just basic electrolysis. Like I said, depending on what liquid you put on this, is depending on how quickly it will start eating away at the board. And 4 minutes for this one, you can see that it looks like it's eaten the cap side, the power side of the caps at the top there. You see how it's shiny on one side and dull on the other. That probably is just surface, surface damage. You can clean that off if I put a bit of flux on there like it is now and then touch those up with the soldering iron. It'll probably go back to being nice and silver. Obviously that's 4 minutes. You leave this on here for 24 hours overnight and not dry it out, or even worse, 3 or 4 days, you're adding the electrolysis into corrosion and stuff. You're in like murky waters, whether anyone's going to be able to repair it or not. So, I mean, even an hour like this without disconnecting the battery is quite a large amount of damage. So let's get the alcohol one last time. Let's get the remaining flux. But you can see when you get a short under an IC, how quickly it heats the board up with a short. So let's turn the board on. We'll put power into the board and we'll test the voltages across there, see if they've changed. We want the VC back. Okay, have we got any power in this cap? Yeah, my camera's stopped. So I've got 3.8 on there. If I just run my hand in front of that, yeah, the camera's stopped. Hold on. Might just be because it's out of view. No, it's completely stopped. I'm not going to bother sorting that out. You'll just have to take my word for it. VC main on that one. Have we got VC back? .849. That'll do for me, pig. Okie dokie. So I'm going to conclude that live stream there. I just wanted to do a quick demonstration of liquid on a board with electric running through it and how quickly it can eat away at your stuff. And yeah, sort of pass on a bit of information to show to people what damage is happening. So you might have your phone, you drop it in the liquid and go, oh look, it's still working, we'll shake it off. There can't possibly be any liquid inside my phone. But you see there, it will keep running. But what's happening is you've got electrolysis going on inside your phone and it's eating away at certain chips, and not great. Not great for your board. So get it into a repair shop, get them to clean the board properly. If they clean it, your phone's got a good chance, and the quicker you get it to them, the quicker you get it to them, the longer that repair will last. The longer you leave it, the less chance that repair shop's going to have of doing any repairs on the phone and it having any lasting effect, if any. I mean, we don't really do liquid damage repair. We'll assess the damage on the board and see if it's worth repairing. If it looks like that sort of damage up in the corner, I will repair that. We'll pull the chip, we'll clean everything up, see if it works, if it's localized. If it's across the whole board, it's just not economically viable to be able to do that. So the quicker you get it into a repair shop, the quicker they can clean it to stop this sort of excessive damage, and then you're not going to have that issue. So, as always, thanks for watching. I'm going to do a couple more of these. I think I'm going to do what Rossman did. We're going to do the Coca-Cola. He is in America. He's on a different time scale. We've got a different group of people here. It'd be good to share the knowledge. And if you've got any, suggestions for liquid that we should be putting on these, leave a comment down below. And if you're on Facebook, obviously leave a comment on there. And as always, thanks for watching. If you're on YouTube, like and subscribe. If you're on Facebook, hit the like page. And thanks again.